Hi, welcome to this video. In this, we are going to discuss the patient ventilator cycling and the last topic, the protection circuit for the unit number 1. So, in the patient cycle ventilators, so it is a very key element in optimizing the ventilator concept. That is, the change from inspiration to expiration is a crucial point in the mechanically ventilated breath, and it is termed as a cycling. So the patient ventilator asynchrony may occur if the flow at which the ventilator cycles to exhalation and doesn't coincide with the termination of neural inspiration. So the cycling mechanisms in the patient cycle ventilators, it is a mechanical ventilator breath occurs after a set value is reached. So these values are often referred to as cycle variables. So several variables are pressure cycling, time cycling, volume cycling, and the flow cycling. Let us discuss one by one. When you go for a pressure cycling, when a certain pressure threshold is reached, the inspiration is cycled into the exhalation. The most common application for pressure cycling is for alarm settings. That is, if a patient becomes extremely asynchronous or cough situation, the high pressure alarm may be triggered and the inspiratory phase ends, resulting in exhalation. So the pressure cycling can be viewed as a safety feature to avoid the elevated and sustained inspiration pressure. When you go for time cycling, so it indicates the mechanical ventilator breath switches from inspiration to expiration after a set time threshold is reached. So this can be accomplished by setting the respiratory rate, inspiratory time, or inspiratory expiratory ratio. So these ventilators terminate the inspiratory phase after a certain time frame, so typically 3 to 5 seconds. So this is a time cycling values. When you go for volume cycling, so with the conventional volume targeted breath, the inspiration stops once the target volume is delivered. So this is the first one. So the ventilator cycles to expiration once a set tidal volume has been delivered. So the volume cycling is only adjustable as the clinician sets a tidal volume to be delivered or maximum tidal volume alarm setting is notified. So these are the important terms of volume cycling. When you go for the flow cycling, so all the other terms when compared with the pressure cycling, so this flow cycling has received the most attention and has been subject of numerous clinical investigations. So we will explain this flow cycling with the help of this diagram. In the x-axis we are having a time, and in the y-axis proximal airway pressure. So this is a characteristics of pressure supported breath. So in this, the example, the baseline pressure, that is the PEEP is 5 centimeter H2O, and the pressure in support is set as 15 centimeters. So 20 minus 5, 15 centimeters H2O. So the inspiratory pressure is triggered at point A by patient effort, so resulting in an airway pressure decreases. So the rise to pressure, that is line B. This one is our line B. Line B, it is provided by the initial flow into the airway. If the initial flow is excessive, so the initial pressures exceeds the set level. So this is a B1. In the same way, if the initial flow is low, there is a slow rise to pressure, that is a B2. Okay, so the plateau of a pressure support, that is a line C, is maintained by the control of flow. So the smooth plateau indicates the appropriate flow responsiveness to patient demand. So based on the conditions, we will just see the conditions of the various variables. Once if it exceeds, we can go for the treatment. So the termination of pressure support occurs at point D. and should coincide with the end of neural inspiration. If the breath termination is delayed, so the patient may actually exhale, that is the pressure rises above the plateau, that is a D1. If the breath terminations are premature, the patient may have a continued inspiratory effort, D2. So these are the concept of that is a flow cycling. So this is a idea behind the patient cycle ventilator. Next we will move on to the protection circuit. So in the why we can go for the protection circuit means it is helps to ensure the safety of the device and the working conditions, and it also prevents the damage on the electrical systems. And most of the devices having the protected device, and it also protect from the risk of the injury, and it also includes the circuit and the fuse. So there are two types of protection circuit. There are two devices we are going to protect the circuit with the help of a fuse and with the help of the circuit breaker. So this is a very familiar one. This is a fuse device, and there is a type of low resistance resistor to provide the overload protection. So there is a small wire inside in this fuse. Next, when you go for the circuit breaker, it is a switching device that can be operated by means of manually or automatically for controlling and protecting an electrical power device. So this is a very familiar one, and we can go for all type of electrical devices. We can go for this braking device to protect our electrical systems. So it consists of two main contact. One is a fixed contact, another one is a moving contact. So the contact are normally closed and allow current to flow through the circuit. So this is a basic idea. Once when a fault occurs, that is a short circuit or a overload, so the contact are separated by the mechanism that releases the stored potential energy. So this mechanism, so this is one is idea of a circuit breaker. So this mechanism can be spring operated or pneumatic or hydraulic or magnetic type. So these are the examples of the circuit breaker. So the separation of contact creates an arc between them, which is a highly ionized and conductive plasma. So the arc can damage the contact and surrounding equipment if it not extinguished quickly. So this is a circuit protection device for the our therapeutic equipments. So thank you. These are all the reference for this unit number 1. So once again, thank you for your patience to watching this video.